What's up, guys? Yeah, so let's solve this 149 max point online, and this problem is interesting, and I spent some time and try to code my own idea up, and yeah, it's very similar to the answer, but I think it's a little bit different. Yeah, so let me just give you my opinion, right? So you get some points on the two, you get a point set, and you need to find a line which maximum the points that I pass. For example, it's 3. This is 4. Okay. And actually, mathematically, there's a theorem called Savistor. You can prove that if all the points are not collinear, then you can always find the points, or you can always find a line which pass 2 points. But this is not important. Okay, because this is not mathematics. Okay, so yeah, so let me just tell you the two solutions. Okay, so the first solution is the first solution. Okay, so the first solution is brute force. Okay, so this solution is basically, I suppose somebody, so for each pair, let's say sorry, right, so let's say for each pair, for like x1 y1 x2 y2, you can enumerate all the other, you can enumerate all the other x3 y3 and check s3 y3 is on the line, on the line pass, let's say p1 p2 p3. So basically, let's say p1 and p2, and for each 2 points, you can create a line, and you just enumerate all the p3 points, whether this p3 is on the p1 and p2. Okay, so this problem, this solution is basically, since all points are unique, right? So you can prove, you can say this is true. You can, so any 2 different points will give you one line, and then you just check it. Okay, so how do you check where these 3 points are on the same line? So the idea is the determinant, right? So you can prove that the p1, p2, p3 are the same line, are on the same line. If and only if, right, you can ask the determinant. So x1, y1, x2, y2, x2, y3, 1, 1, 1 is 0. Okay. So you can just write it up. Okay. So let me just write down the answer. Right. So the answer is that you define a result to be 0, and then it's points. And if it's n is that equal to 1, that means you only 1 point. Right. 1 point must be 1. Then the sorry, let me just, I think there's the original version. The original version has duplicated, but in the new version, there's no duplicate. So my previous version has duplicated. Yeah, this is no duplicate version. So rest is 0, the answer is points. And if n is 1, return 1, right? Else that you can forget about is duplicated. You just go through I to n minus 1 and j to I plus 1 to n, and you take any 2 points. This is the point, right? x1, y1, x2, y2, and count 0. And then for the rest points, you just take the points. You have 3 points, x1, y1, x2, y2, x3, y3. And then you compute this guy is 0. This guy is determinant. We just expand it. And then if it's 0, that means it's on the pair of, it's on the p1, p2. So count at 1 and update the maximum. Okay, so this is the brute force algorithm. And you can pass. Okay, you can pass all the tests. But I think it's 5% or something. This is a little bit slow. Okay, so this this algorithm take the O to the cube time. Correct, right? Because you got n squared pair and the rest 2 points. Okay, so it's O n squared time. So this is the first solution. Okay, yeah, let me explain this. So this is the second solution, which is way much better than the brute force. If you use the brute force, I think it's 5%. And then for this one, you only take 91%. Okay, so this is what I come up, basically follow the solutions, but a little bit different. So basically, this idea is the following, right? So let's suppose you get these all these points, and you take one each one, right? Each point, and you iterate all the iterate all the slope, all the slope. Right? I mean, if the slope are the same, then you just add it. Right? So you need a map, you need a dictionary to remember the slope. Okay. So the idea is that how to remember a slope. Okay. So for example, let's say this is x1, y1, and you get xi, yi. Right? So you can calculate the d1 to be xi minus x1, d2 to be yi minus y1. Okay, and you need to remember a slope. So the naive way will be you create a dictionary and you just remember, let's say, d2 divided by d1, right? But this is may cause some problem because there is a division here. So it may cause a lot of trouble, right? So one idea is that you calculate d to be the GCD of d1 and d2, and then you collect d1 divided by d and the d2 divided by d as the keys. Okay. Now this is the answer, but there is a subtlety. So for example, if d1 is 0, that means what? If d1 is 0, that means all the line are the same, right? So if there's a 1 0 and the minus 1 0, sorry. If d1 is 0 means that they are on the straight line, right? So suppose there are 3 points, and then you start from here. Then this will give you this d1 d2 pair is d1 d2. This d1 d2 pair will be 0 1. This d1 d2 pair will be 0 1, 0 minus 1, right? But these two, if you use d1 divided by d, d2 divided by d, there are different. Okay, so you need to tackle with this kind of case. So the idea is that if d1 is 0, then every point should use the same slope. Okay, so in this case, that I should manually force. If d1 equals 0, then I should just set m of 0 1 at 1. Okay, so if d2 is 0, I should manually set the m 1 0 is 0. Sorry, plus or equal to 1. Okay, so this is what the 2 boundary cases. Okay, there are for third boundary cases. There are some boundary cases. For example, minus 1 and 1 should be viewed as the same as 1 and minus 1. So I can manually force d1 to be positive, right? So if d1 is positive, then I can just add md1 d2. These two at equals 1. If d1 is negative, then I just manually force that minus 1 times d1 minus 1 times d2 plus or equal to 1. That's enough. Okay, so we can solve the problem. So basically, you define the result to be 0, length of points, that's equal to return n, slope defined to be a dictionary, right? So you fix a point and you define a dictionary, and you take out the points x1, x2, and you iterate all the points, all the other points, right? So you get s2 and y2, and you get d1 and d2, and then you get d. So the idea is that you need to use the slope dictionary to store a slope. And then the boundary case is that if d1 is 0, then everyone is on the y-axis. If d2 is 0, then everyone is on x-axis. And also remember that minus 1 and 1 minus 1 are should be the same, right? So if d1 equals to 0, and you add 1. If d1 is less than 0, then you manually force the first coordinates to be positive. Also, this is all the boundary cases that you need to handle. Stupid, right? Then for every time you finish your points, then you just ask what is all the possible values. If their slopes are the same, they must be the same. Finally, your results must add 1 because you forget about the original point that you choose. Right. So this is the answer for solving the second solutions. See you guys. Subscribe to my channel. See you guys next videos.